In this video, we'll practically verify the BGP community attribute. Now we'll see how exactly we can tag a specific routes when they are getting advertised to another autonomous system member. So we'll see how to define that community tagging with some specific routes by using route map statements. And then we'll also practically verify how the upstream router, assuming that this is my service provider, how the upstream router is going to match those tags, how it is going to write the community list, and then how it is going to use the local preference or wait attributes, which can be used for path manipulations by matching the community values. So this is my scenario lab. I'm going to take the same 4 routers which I use for all my labs, but I have router 1 is configured inside your autonomous system number 500 and the remaining 3 routers are configured in the AS600. So I'm going to assume this is my autonomous system number and maybe this is your service provider autonomous system number. Now I have created a small requirement or a small task. What we are going to do is we are going to advertise 4 different routes from here. If you see, I got 4 different routes: 11.0.network, the loopbacks of router 1, 11.0.0.0, 1.0, 2.0 and 3.0. So when I'm advertising these routes to router 2 or router 4, advertising to autonomous system 500, we are going to advertise with a community information of 500:10. So assuming that this is the community tag which we want to apply, and the service provider wants us to advertise our networks with a community tag information. In similar way, we are going to advertise the remaining 2 networks when we are advertising to autonomous system 600, sorry, it's 600. We are advertising to 600 with a community tag of 500:20. So our requirement is we need to advertise our networks maybe in 2 categories with a community value of 500:10 and 500:20. Now, which means the routers inside the autonomous system number 600 will receive the routes with a community value of 500:10 and 500:20. Now based on that, now the service provider is going to do path manipulation, and I have created one small requirement that okay, the requirement is any routes whichever coming with a community tag of 500:10. So in my example, it's going to match these 2 networks. Maybe in the production networks you may have more than 2, or maybe you may have the same routes coming from a different customer. You may have one more customer connecting and advertising with the same community value and one more customer. But here for verification, we are just using just one customer side, that is router 1, and any routes coming with this tag should prefer to exit via router 2. Means all the routes going outside our autonomous system number should prefer like this. So for that, we are going to apply the local preference value of 200 or 250, whatever the number. And all the routes which are coming with a community value of 500:20 should prefer another exit path, that is router 4, should prefer router 4. And we are going to apply the local preference value something higher, let's say 250, only for the prefixes which are coming with a community value of 500:20. And all the prefixes coming with a 500:10 should prefer the exit via router 2 with a local preference value of 200. This is my requirement here, a small task or the small lab which I configured. So let's try to verify all these things. So the first thing, to implement all these things, we need to have some basic pre-configurations. Now to implement and verify this, we need to do some basic initial configurations, like we need to configure OSP of inside the autonomous system number 600 to provide reachability, because this is same autonomous system number and we have 3 routers. We need to have full mesh neighbor relationship, or we can also use route refactor concept. So I'm going to configure IBGP peering inside the same autonomous system number using loopback interfaces, and to provide the reachability to loopback, we are using OSP of area 0 inside the autonomous system number 600. So the first task will be we need to configure OSP of inside as an IGP inside your autonomous system 600 to provide the reachability. And then the next step will be we need to configure IBGP and EBGP configurations. Now all the EBGP configurations will be using directly connected interfaces, and the remaining all IBGP configurations, the internal BGP configurations, are done by using the loopback interfaces. Or you can also use connected interface also, but here as per my requirement, I'm using loopback interfaces here. So this is something pre-configured in my routers here. So to verify, I'll go to router 3. If I go to my router 3, Router 3 is already pre-configured with OSPF configurations. If I give show run section OSPF command, router 3 is already advertising its own connected interfaces and the loopback interface and the LAN interface. And similar way, the same thing on the router 2 also. Now I already did this configuration, so BGP is also configured. I'll come to the BGP configurations later on. I'll go to router 2 and I'll show you the OSPF configurations, advertising the WAN interface, 2 network, 20 network, and the loopback interface, because based on this loopback we are going to form the neighborship. Now similar way, router 4 is also configured with OSPF, advertising all the connected interfaces and the loopback and the LAN interface, whatever facing inside the AS number 600. And to verify, I can go to router 3. If I give show IP OSPF neighbor, I should see two neighbors, router 2 and router 4. And if I give show IP.OSPF, I should be able to receive all the routes coming from router 2 and router 4. So router 1 belongs to different autonomous system numbers, so we are not going to configure any IGP towards router 1. Now the next thing what we are going to do is we just configured this first task already. It is pre-configured here. And the next thing, we are going to configure IBGP peering using loopback interfaces and the eBGP peering using all the connected interfaces. Okay, so that is also pre-configured here. So I'll go to directly router 1 and I'll show you the configurations what I did, because you are very well aware of this configuration, so I'm not going to configure them here. It's already pre-configured before I started. So the router 1 is peering with router 2 and router 4, and these are the two neighbor commands, router 2 and router 4. And I'm advertising all the 4 loopback interfaces of the router 1, as you can see in the diagram here, 11.0.0.1, 1.1, 2.1, 3.1. And also I'm advertising the 3 connected interfaces, 2 WAN interfaces and 1 LAN interface. So router 1 is forming the neighborship with router 2 and router 4 as eBGP neighborship. And if I go to router 2 and verify the router 2 configurations, now router 2 is peering with external BGP neighbor, and there are 2 internal BGP neighbors. So which means total there are 3 neighbors. And if you try to see here, these are the neighbor commands. One is external BGP neighbor. This is my external BGP neighbor. And then internal BGP neighbor using loopback interfaces, so remote AS and update source, and advertising the LAN and the WAN interfaces. Now if I go to router 3 is having only 2 internal BGP neighbors. So router 3 form neighborship with router 2 and router 4 neighbor commands and advertising the interfaces. Similar way, router 4 is also pre-configured with BGP, show run section BGP. Now router 4 is forming 1 eBGP neighbor with router 1 and 2 internal BGP neighbors and advertising the LAN and the WAN interfaces. So OSPF and BGP is pre-configured here, and you know the basic configurations. You can find the same thing in my workbook here. So the OSPF and BGP is pre-configured. And verifications, to verify, I can go to router 2. Now router 2 must have how many neighbors? 2 internal BGP neighbors and 1 external BGP neighbor. So these are the 2 internal BGP neighbors and 1 is external BGP neighbor. Similar way, I can verify on the router 4 as well. Show IP BGP summary, 1 eBGP neighbor and 2 internal BGP neighbors. So all the routes are coming. So if I give show IP BGP, I can see the 11 dot prefixes are also coming here, and the 20 dot network, 30 dot network, 40 dot network coming from router 2, 3, 4. So I'm able to receive all the prefixes. So next thing, so coming to our actual requirement. So what is our requirement here? Now we need to configure router 1. So we are going to configure router 1, and what is the task here? Configure router 1 to tag the 11.0.0.0 and 1.0 networks, the loopback 0 and the loopback 1 interfaces with a community value of 500:10. And we are going to tag 11.0.2.0 and 3.0 with a community value of 500:20 when it is advertising to autonomous system 600. So here my requirement is, I want to ensure that when my router 1 is advertising these 2 prefixes, the first 2 should get advertised with a value of 500:10, that is the community value which we are going to apply, and the remaining two loopbacks should get advertised with a 500:20. These are the two community values when they are getting advertised on both the sides, not only one side, it has to be applied on both the sides. So how to do that? Now it's very simple. Just like we did route filtering, we need to match the first category of the networks in one ACL. So I'm going to match 11.0 and 11.1 in ACL 11, and I'm going to use 22 ACL for matching the remaining two networks. And then we need to create a route map, and we have to say match IP address 11, which means I'm going to match these two networks, and we have to give a command called set community. Now when I'm giving set community, we are going to apply the community value. Now when I say set community, you'll find multiple values, like you can define in an older format or you can define in a newer format. And these four values, whatever you see, these are well-known communities which we have already discussed in a separate section in detail. Okay, so even you can add to the existing community value by using a command called edit. Now as of now, I'm using this format, and the format is 500:10, where 500 is my autonomous system number and 10 is a number which I'm attaching to those routes. Now similar way, in the same route map, we need to match the second ACL, which is going to match the second category of the networks, and we have to give this command called 500:20.